Hello friends, today we will discuss some basic questions from organic chemistry. So let's start the questions. Question number 1. What is bond dissociation energy? Answer is the amount of energy per mole that is given off when a bond is formed, or the amount of energy that must be put into break the bond is known as bond dissociation energy. Question number 2 is what gives the covalent bond its strength? The answer is it is the increase in electrostatic attraction which gives the covalent bond its strength. Next question is question number 3. What is the concept of overlap that provides the mental bridge between atomic orbitals and bond orbitals? So the answer is in the isolated atoms, each electron is attracted by one positive nucleus, and in the molecule, each electron is attracted by two positive nuclei. Next question is question number 4. What do you mean by overlap of atomic orbitals? It means that the bond orbital occupies much of the same region in space that was occupied by both atomic orbitals. It is the concept of overlap of atomic orbitals. Next question is question number 5. What is the length and strength of hydrogen-hydrogen bond? So the answer is hydrogen-hydrogen bond has a length of 0.74 Armstrong and a strength is 104 kilocalorie. Next question is question number 6. What is the length and strength of fluorine-fluorine bond? So the bond length in fluorine-fluorine is 1.42 Armstrong and strength is 38 kilocalorie. Question number 7 is what do you mean by sp hybrid orbitals? So for considering sp hybridization, we will take an example of beryllium chloride. We know that the atomic number of beryllium is 4. So its electronic configuration is 2 electrons in 1s, 2 electrons in 2s, and there is no electron in 2p orbitals. Now promote one of the 2s electron to an empty p orbital. Here you can see the sp hybridization diagram. Now beryllium has 2 unpaired electrons. As we hybridize the orbitals, it is known as sp hybridization. The angle between the orbital is thus 180 degree. We know that chlorine's atomic number is 17 and its electronic configuration is like that: 2 electrons in 1s, 2 electrons in 2s, there are 6 electrons in 2p orbitals, then 2 electrons in 3s orbital, and there are 7 electrons in 3p orbitals. So it has one unpaired electron in p orbitals. Now beryllium chloride is formed by overlap between the sp orbitals of beryllium and p orbitals of the chlorine. Bond formation of beryllium chloride is taken by overlap of sp and p orbitals, the sigma bond orbitals, and the bond angle is 180 degree, as you can see in the diagram. Next question is question number 8. What do you mean by sp2 hybridization? Now for sp2 hybridization, we will take an example of boron trifluoride BF3. You know that boron atomic number is 5 and fluorine atomic number is 9. Electronic configuration of boron, as you can see, 2 electrons in 1s orbital, 2 electrons in 2s orbital, and 1 electron in 2p orbital. Now boron has only 1 electron which occupies a 2p orbital, as you can see in the diagram. Now for 3 bonds, we need 3 unpaired electrons. So promote one of the 2s electron in 2p orbitals. You can see in the diagram. Now there are 3 unpaired electrons and it is known as sp2 hybridization. You can see BF3 molecule, B boron in the center and 3 fluorine molecules. The bond angle is 120 degree. It is the example of sp2 hybridization. Now next question is question number 9. What do you mean by sp3 hybridization? We have seen earlier sp and sp2 hybridization. Now we will discuss sp3 hybridization. We will take an example of CH4 methane molecule. We know that carbon's atomic number is 6. 2 electrons in 1s, 2 electrons in 2s and 2 electrons in the 2p orbitals. Now we will promote 1 electron in the 2p orbitals from 2s. 1 electron from 2s orbital is promoted to 2p orbitals. As you can see in the diagram, it is known as the sp3 hybridization. And you can see the bond formation of CH4 methane molecule. It is tetrahedral sp3 orbitals, H nuclei located for maximum overlap. Its bond length is 1.10 Armstrong and bond angle is 109.5 degree. You can see the shape and size of the methane molecule, which is tetrahedral sp3 hybridization. So thank you for watching the video.